Hello everyone. In this video I'm going to show you the answers to the answer to the exercise on slide number 17. Alright, so it says you are given a vector u is equal to the unknown value minus 1 and 0. Okay, and then you are told to find that unknown component if u is a unit vector. Now, what do we know about a unit vector? We know that a unit vector, if we find the absolute value, if we find this, we must get a 1. So meaning that if we, let's say we have a vector v is equal to a, b, and c, alright? So if we find its absolute value, we are actually doing this: a squared plus b squared plus c squared, and the answer should be a positive 1. Alright, and if we get that, we can say that v is a unit vector. So we do the same thing to this one. Alright, so let's do it. So what we have, we say absolute value of u is equal to root x squared plus negative 1 squared plus 0 squared. Okay, but then we know that if this is an absolute, if this vector is a unit vector, then everything is just equal to 1. So we have x squared plus, so this is now positive 1 plus 0, of course, everything under a root will be equal to 1. So what we are trying to find is the value of this guy. Okay, so what do we do now? So we say, so we square on both sides. Why do we square both sides? Because we want to remove the square root. We end up with x squared plus 1. I don't want to add the 0, please. So just equal to 0. Okay, and then I can take this on the other side. This is not 0. This is 1. Sorry. So 1 squared is just 1. So if I take this on the other side, so I'll get x squared is equal to 1. This 1 minus this 1. And then I'll end up with x squared is equal to 0. Okay, so if I take a square root on both sides, I'll end up as x is equal to just 0. So that's how I work it out. Okay, so meaning that this is 0. Let's put it in C. 0 minus 1. That looks like a unit vector. Okay, alright, so that's how I work it out. Alright, so the next one, it's gonna be the question or the exercise on slide 21. Okay, so let's quickly go to slide 21. So I should have said slide 17 and 21. So let us go to slide 21 and see what is there. So what do we have on 21? On slide 21, we are given something like this. We are told that a vector, a matrix with these components, x minus 4y, 2z plus a t, z minus a t is equal to 3, 1, 7, and 5. So if you are given this, what you need to do is to equate. So you need to equate this to that and form an equation. So you have x plus y is equal to 3. That to that will give us 2z plus t is equal to 7. And then this will be x minus y will give us positive 1, and then z minus t or z minus t will give us positive 5. So now we have 4 equations that we are going to solve. If you look at these two, they have x and y, x and y. And these two have z and t, z and t. So we can solve this simultaneously, and let's see what we're going to end up with. So let me start with the first two, and then I'll remain with these last two. So now, solving sim equations. So we did this in high school. We call them simultaneous equations. So solving sim equations. So positive 1. So I want to eliminate y. So I'm going to add. So the signs are different. I'm just going to add. So 1x plus 1x, I'm going to get 2x. Y plus negative y, they'll cancel each other. Now we get a 4. 2x is equal to 4. If I divide both sides by 2x, give me a 2. I got the x, I should now find the y. So I can just take the first equation. If I want, I can take the second equation. Then 2 plus y will give me 3. Therefore y will be 3. Take away 2, which is 1. Okay? So that's the answer for the first two equations. Okay, so you can check if you're right by substituting this in the equations. You must get the answers. Okay, so let's do the z and t equations. So I have 2z plus t should give me 7. And I have z, take away t, they should give me positive 5. So I'm going to eliminate the t, so I'll add because the signs are already different. So 2z plus 1z, I'm going to get 3z. Plus 0, of course, because these two guys are going to cancel each other. 1t plus a negative t, I'm going to get 0. And then 7 plus 5, that should give me 12. So I have 3z is equal to 12. Alright, therefore z is equal to 4. If I divide both sides by 3, so 3z divided by 3 will give me the z, and then 12 divided by 3 will give me a 4. So now I can take the z and put it in this equation, the simpler one. So z take away t is equal to, come on, 5. So 4 minus t is equal to 5. Okay, and then I can say 5 that's not true, G. 4 take away 5 will give me positive t. So I brought 5 this side, I took this one this side. So minus 1 is equal to t. So z is equal to 4 and t is equal to negative 1. So please confirm these values into the original equations. See if you're going to get that answer. Alright, so in the next video, I'm going to show you the answers